Find the point-slope form of the equation of the line passing -2, 4 and 1, 2. When it comes to line equations, you have to remember very important two formulas, which is first the slope equals the change of y over change of x. And then the next important formula is the point-slope form, which is y minus y1 equals to m times x minus x1. Now we're going to use these two formulas to solve this, so let's try this. First, you have slope m equals to, well, change of y is the change of the y coordinates. These are the y coordinates. Let's call this y1 and y2. And change of a quantity is always the final value minus the initial. So it's 2 minus the initial value, which is 4. The same way, it's the for the change of x. For the change of x, you have the final value x2 here, and then x1 will be this negative 2. So 1 minus negative 2. 2 minus 4 is negative 2, whereas 1 minus negative 2, that's 3. So you have this negative 2/3 as the slope m. Now that we have this slope, we can write down y minus y1, and because our y1 is 4, I'm going to put 4 here, equals the slope, which is negative 2/3, that's your m, right? And then x minus x1, which is negative 2. Oh, sorry, yeah, this is correct. Okay, so if I simplify this, this is y minus 4, negative 2/3, x plus 2. Now you can further simplify this and multiply them out and then add the 4, but that would make this form as y equals to mx plus b, which is, we call this the slope-intercept form, right? This form is what we call, this formula here is what we call the point-slope form. So, point-slope. And therefore, we don't want to multiply and simplify. This is where we want to stop, because this is the point-slope form. Okay? Alright. Next was find the slope-intercept form. As I said just a moment ago, y equals to mx plus b is the slope-intercept form of the equation of the line through 6, negative 4 and parallel to negative 2x plus 3y equals to 6. First, in any case, when you're trying to find the equation of the line, you should always think about the point-slope form. This is a very important form of point-slope form, and this pair of x and y values will be our x1 and y1. So when you try to plug things into this point-slope formula, you see that x1, y1 is given, but I have no idea what m is. So let's read the question again. Find the slope-intercept form of the equation of the line through 6, negative 4 and parallel to this. So what is this parallel? Well, if you have two lines that are parallel, you know that their slopes are exactly the same, right? Because their slantedness is the same thing. So what you want to do is you first want to change this into y equals to something times x plus something, because then this will be, this coefficient of x is your slope, as you can see here. Alright, so just to make things more clear, let me do step one by one. So step 1, solve negative 2x plus 3y equals to 6 for y. Okay? That makes it into this format, which will give us the the slope-intercept form. Okay, I'm going to add 2x both sides because I'm trying to isolate y, so 3y stays, but 2x has to go, so we have 2x plus 6. And then since I want to isolate, I want to solve for y, I want to divide both sides by 3, and that gives you y equals to 2 over 3x plus 2. So the line that we're given is a line that has the y-intercept 2, but the slope 2/3. Therefore, we know that parallel lines that are parallel to this have slope 2/3. Okay? And that's what we're going to use for the second thing. So step 2, use point slope form, which is y minus y1, which is -4, 2/3, x minus x1, and that's 6. And this is y plus 4 equals to 2/3 times x, and then -2/3 times 6. Well, 3 and 6 cancels, because 6 divided by 3 gives you 2, right? 2 times 2 is 4. So we have 2/3 x minus 4 as the right side, and then you want to isolate y. If you solve for y, that's your slope-intercept form. Okay, so I might say step 3, solve for y. Okay, and then you subtract 4 both sides. 2 times 2 is 4, minus 4 minus 4, that's 8, so you end up with y equals to 2/3 x minus 8, and that's your answer. That's the line they want you to find, and this is in slope-intercept form because slope is 2/3 and -8 is the y-intercept. You have a function f of x negative x cubed times x plus 2 squared, and the first question is find the y-intercept. To get y-intercept, you need to plug in x equal to 0. So let's see what you have for y. And by the way, sometimes you're just given the function, but because when you are making the graph of a function, you're really trying to make the graph of y equals to f of x. So your fx should be replaced by y when you think about the y-intercept. In other words, think about this as y equals to negative x cubed times x plus 2 squared, and plug in 0. Whatever value you get is the value of the y-intercept. So let's plug that in. If y equals to negative 0 cubed, 0 plus 2 squared. See, all the x's are being replaced by 0. Right now, 0 is not a negative number, so you don't need this parenthesis, but it's a good habit to always put a parenthesis when you're replacing one by the other. Okay? And 0 cubed is 0, so you have 0 times 2 squared is 4. But what's 0 times 4? That's just 0. So that's your y-intercept. Now, whenever you write down the y-intercept and x-intercepts, these are points on the plane, so you really need to write down both x and y coordinates. So since when x is 0, y is 0, this result says on the graph there is this point 0, 0. And 0, 0 is exactly where the graph passes through the y-axis, so this is what we call the y-intercept. This is the answer to A. Now for B, we want the x-intercept, and to do that you set y as 0. And if you replace this y by 0, let's see what you get. 0 equals to negative x cubed, x plus 2 squared. And the structure on the right side is that you have something here multiplied by another thing. And we also know that whenever two or more things are multiplied to create 0, that means at least one of the factors must be 0, because if none of them are 0, how can you have a multiple which is 0? That's impossible. Okay? So we know that either negative x cubed is 0 or x plus 2 squared is 0. Let's think about this case. If I multiply by negative both sides, you get x cubed equal to negative 0, but puts a 0. And then to get rid of this cube, you would take the cube root both sides. Cube root. And what is the cube root of cube? That they just cancel and you just get x. And cube root of 0 is 0, because if you take 0 cubed, it's 0, right? So therefore cube root of 0 is 0. Over here, you can take the square root both sides. And whenever you have a square, then you can get rid of it by taking square root both sides. But one thing that you have to be careful is that you need to put plus or minus square root. But square root of 0 is 0, so that doesn't matter. Either plus 0 or negative 0, they both give you just 0, so you just have x plus 2 equal to 0. So you get x equals to negative 2. Okay, these are the places where the graph hits the x-axis, and as before, I need coordinates. So when x is 0, y is 0. When x is negative 2, y is 0. So in coordinates, it's 0, 0, and negative 2, 0. These are the x-intercepts of the function f of x. Let's continue with the same function. Explain the behavior of fx at its x-intercepts. Well, the x-intercepts that we had were 0 and negative 2. Negative 2 comes before and then 0. So if you draw the x-axis on the graph, there will be the negative 2 here and then 0. Those are the places where this graph would be passing through. Right now, I'm not so sure if it's going to come down like that or go up like that, but what we do know that it has to pass through these 2 points. But what does it mean by the behavior? Well, the behavior is about when you pass through an x-intercept. Sometimes it might touch it and then come back, or sometimes it might go through. And to figure out which one it is, what you need to do is you look at the powers of the factors, each factor. So if you look at this f of x, let's rewrite it. F of x is negative, x by itself is x minus 0, right? And then x plus 2 is like x minus negative 2. The reason I'm doing this is so that you can clearly see which factors are responsible for producing these x-intercepts, right? So this one is responsible for producing the 0 one. This one's responsible for producing the negative 2. And the powers here, those are called the multiplicities of the zeros. So these numbers 0 and negative 2, not only these are called the x-intercepts, but these are also called the zeros of the polynomial, or sometimes the roots of the polynomial. And the roots or the zeros of the polynomials, they sometimes have these powers, and those are called multiplicities. Now, see that the power of x minus 0, the factor responsible for producing this, has odd multiplicity. So you can think of this as an odd multiplicity 0. And let's use root, because 0 is a little confusing. So 0 is a root which has odd multiplicity, and negative 2 is a root of the polynomial which has an even multiplicity. And when you have the odd and even multiplicities identified, then what you know is that when it's even, so at x equals to negative 2, graph does not cross x-axis. And that's because it's a even point. So when it's even, it either goes like this and bounces back this way, or if it was something that was coming from up there, it would bounce back and go like that, okay? And then at x equals to 0, in this case, x equal to 0 is produced by this, and that has an odd multiplicity, and therefore the graph passes through the x-axis there. Okay, so that's how you do C. And now let's look at D. End behavior is about the far end of the graph. Like, I mean, polynomials do something crazy over here, but far end, you basically have just either going up or going down. That's the two kinds of behavior that's possible. And this way also either goes up or goes down. So those are the four possibilities. In other words, you might have end behavior that's like this, or like this. So this is one end behavior. Another end behavior would be like this. Another end behavior would be one going up, and the other one going down. Another end behavior will be going down but going up. Okay, so you basically have four choices. So if some question asks, determine the end behavior of fx, you just have to choose one of these four. So it's a multiple choice question, pretty much. Alright. So let's see, for our case, we have let me just erase this. We have this function, and the end behavior is determined by the highest order term, or the leading term. So if you expanded this, what kind of leading term would you get? You get negative x cubed, and then when x is expanded, when x plus 2 squared is written as x plus 2 times x plus 2, then this times this the FOIL will create x squared, and then you're going to have other terms, right? So the leading term, the highest order term produced by x plus 2 squared would be x squared, and multiply by that to this other one will give you the leading term as negative x to the fifth. Now I'm being a little lazy here because I don't want to actually calculate the expansion of this, but you can pretty much tell that if you had the time to do all this and you multiply by everything by negative x cubed, then the highest order term would be this one. Now, it's like this. Negative x to the odd as the end behavior. They'll be going up and going down. Okay. The reason is, just think about some big number, x to some odd number, like 3. If you plug in 100, 100 cubed is 1,000,000. So positive 100 cubed is 1,000,000, but there's a minus, so you get negative 1,000,000. That's a huge, huge negative value. So the end behavior will be going down like that. On the other hand, if you plug in negative 100 cubed and negative, well, negative 100 cubed is still negative 1,000,000, because if you take odd power of a negative, it's still negative. But because these two negatives become positive, you just have positive 1,000,000. So you do see that as you go left, the graph will be going up, 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 very, very high. Okay. So, see, you could choose to memorize all this, all the shapes, depending on the odd or even, but it's just simpler just to think about some big numbers and see what this type of leading term would give you. Okay. Well, in our case, we will have the x to the odd, negative x to the odd, so that's the end behavior. So this is very much the answer. Okay, this is the end behavior answer. Now, E, you have to sketch it. Alright, so let's put both of these two things together. First, the end behavior is like that, and like that. And then, well, let's use a different color for the axis. So here's x and y axis. The graph would be touching be negative 2, and what happens? It goes up because it does not go through. It does not cross. It bounces back, and then it has to turn back to hit 0 because it has to pass through the x-axis at 0. So it goes through 0, and then it has to go down. Okay, so that's what you have. Now, this is almost right, but it's a little misleading. So let me try to do a better job here. See, what really happens is that if you have cubed or any higher odd power, then the graph actually touches the x-axis. It becomes like one of them for a while, and then starts to go down. Okay. So that's like the shape. So at negative 2, it bounces back. At 0, it touches and then goes down. Okay, this is probably one of the most important problems in the entire worksheet. This is about quadratic functions. And here I'm just asking for Y-intercept and X intercept, but the next one, the vertex form, is going to be very important. Okay, so let's try to solve this. First, Y-intercept, you set X equal to 0 to get the Y-intercept, right? So you have the Y value equal to 4 times 0 squared minus 8 times 0 plus 3, which is just equal to 3. And therefore 0, 3 is your Y-intercept. On the other hand, to get the X-intercept, you set Y as 0. Remember, fx is your Y. So you set fx as 0, and you get 4x squared minus 8x plus 3. Well, you could use factoring to find the roots here. It turns out that you can actually factor this. But let's just use the quadratic formula, because 4 times 3, that's 12. That's a big number. Let's just use quadratic. Now, if you are watching this for the second time, I challenge you to stop the video and actually try to find a solution using factoring, and see if you get the same answer as what I get by using the quadratic formula. Okay. So b is negative 8, so negative of negative 8 is 8, plus minus square root negative 8 squared minus 4 times 8 times c, 4 times 3, and then all over twice of a, which is 8 plus minus square root. 8 squared is 64. This is 16 times 3, that's 48 over 8. And that's 8 plus or minus. 64 minus 48 is square root of 16 over 8. And 16 square root is 4, so 8 plus minus 4 over 8. And that's actually two possibilities, right? 8 plus 4 over 8, which is 12 over 8. Or 8 minus 4 over 8, which is 4 over 8. Now, if you reduce these to the lowest order terms, this becomes, since the top and bottom are both divisible by 4, we're going to divide the top and bottom by 4. You get 3 over 2. Or, if you divide top and bottom by 4, you get 1 over 2. Now, remember, this is obtained by setting y as 0, therefore, the x-intercepts are 3 over 2, comma 0, and 1/2, comma 0. Now, right. Another thing that I want to say is, if you did this by factoring, this thing over here would be 2x minus 3 times 2x minus 1. So if you try to do this by factoring, see if you can get this. Okay, then you get the same answer. Okay, so tough and hard part. Turn fx into vertex form. What is the vertex form? You have to remember that first, right? Vertex form is y equals to a x minus h squared plus k. That's the vertex form. And here it's called the vertex form because h comma k is the vertex. Another important fact is that there's a formula for h, only h, okay? H is negative b over 2a. That's another formula that you have to memorize. And that actually comes from the quadratic formula. See, if you have x equals to negative b plus minus square root of b squared minus 4ac over 2a, it turns out that this portion of the quadratic formula is what you have here. And there's a reason for that. This is actually the midpoint of the two roots. And if you have a parabola and you have two roots, at the midpoint you will have the vertex. Okay, well, those are just some additional words to help you remember this formula because this is so important. Let's actually solve it. So, in our case, what is h? H is negative of, b is negative 8. Negative 8. And then a is 4. So this is negative of negative 8, which is 8 divided by 8. That's 1. Okay, so you got the h as 1. And you just need to know the y-coordinate of the vertex. But vertex is a point on the graph, right? So if you have a point on the graph and you know the x-coordinate, how do you get the y-coordinate? You plug it into the x, right? So 1 gets plugged into x here, so you get 4 times 1 squared minus 8 times 1 plus 3. It's a good idea to put parentheses when you plug in. Then you get 4 minus 8 plus 3, which is negative 1. Alright, so the vertex is actually 1 comma negative 1, and the answer to C would be, you get y equals to, a is same as a as this one, so it's 4. X minus h is 1. And then k is negative 1. Okay, we got the k value. And maybe I should just say the k value is when you plug in the h into the function, you get the k value, okay? Alright, now that we have the vertex form, let's try to sketch the graph. No. What's the minimum of this function? Well, this is a graph that's opening upwards, right? So the vertex becomes the minimum point, and because it's asking for the minimum value of a function, value of a function is the y, right? So what is the value of the function at this vertex? Well, we know that's negative 1, so the lowest point on the graph is negative 1, therefore the minimum value of the function is negative 1. E, sketch the graph of f of x. Well, we're going to use all the information that we figured out so far. In the previous slide, we found out that the 0, 3 is the y-intercept, 3 over 2, 0, and 1/2, 0 are the x-intercepts. So let's put that. So let's say this is 1, 2, 3. That's your y-intercept. 1, 2, 3. Well, I know that the two x and y-intercepts are 3 over 2 and 1/2. But 1/2 is here. 3 over 2 is here. So we know that it's going to be passing through these points. It's really hard to draw. Maybe I should have made this bigger. But anyways, that's what we have. This will be 3 over 2. This will be 1/2. This will be 3. And the vertex here would be, we already have h comma k, right? 1 comma negative 1. So this will be 1 comma negative 1. Okay, so you have a parabola. My parabola looks horrible, but it's supposed to be a parabola. Okay. For each function, find the domain and range of the function, find the f inverse, and find the domain and range of the inverse. Okay. First, to find the domain of a function, and you have a square root, that means whatever that's inside of the square root, we call this the radicand. Radicand has to be 0 or greater, okay, because you cannot have square root of a negative number. Square root of negative numbers are called imaginary numbers, and in precalculus we do not allow those as values that functions can produce, because in precalculus we only work with functions that produce real numbers. Okay, so we just have to solve this. But what is this? If you add x both sides, we get this. So it's basically all numbers that's 3 or below. On the number line, here's 3. It's everything up till 3. So it's everything up till here, up till this point. So what is that in terms of domain? In terms of the interval notation, it's from negative infinity up till 3. And 3 is included because this is greater or equal. And negative infinity, you never put a bracket there, it's always a parenthesis. So that's your domain. However, trying to figure out the range requires, I want to actually draw this thing. Let's see how we can draw this. First, you have y equal to square root of x, which is this graph. And the next one, you want to put square root of 3 plus x minus 2. And this is like x is replaced by x plus 3. That moves 3 steps left. And this one, minus 2, is 2 down. So what we have to do is we have to take that and go 1, 2, 3, and 1, 2 down. And then you have, let's see, you have something like this. This graph is now kind of like that. Okay, we're still not done. We still have to say y equals to square root of 3 minus x minus 2. Well, from here to there, x has been replaced by negative x, so that's a reflection over the y-axis. See, if you have x, negative x, y, negative y, and you go from x to negative x, then it flips over the y-axis. Okay, so you end up with something like that, where this point before was negative 3 comma negative 2. Now this is positive 3 comma negative 2. Okay, so now that you know the graph, let's see what the y values are. The lowest point, see, y values is the height of each point on the graph. So at every point, if you look at the height, that tells you the y coordinate. And the y value, the lowest one, is negative 2, and it goes up, up, up until, actually it goes up without bound, so it's until infinity. So the answer to this question is, you say the range starts from negative 2 as its least y value, and upper, if you go up, 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 there is no upper bound. If you go further to the left, it just keeps going up. Okay, but that's just part 1 of our question. We still need to find f inverse of x, right? Okay, so let me just, I guess I should erase some of these. So let me erase this. And then start doing, well, so this will be our answer to A, number 1 of A. 2, we have to find f inverse. Well, how do you do that? Well, first introduce y so that you have something to work with. I mean, really the first step should be exchange x and y, but here you don't have a y, so you have to start out by replacing fx as y, and now you make y as x and x as y. And once you do that, that'll be the first step. And then the next step is you try to isolate y. Okay. So first, y is negated, and then 3 is added, and then the square root is taken, and then finally there's a subtraction of 2. And when you undo things, you do the opposite order. So the last one done, which is negative 2, now you add to both sides. So you have x plus 2 equals to square root of 3 minus y. And then you can square both sides, and you get x plus 2 squared equals to 3 minus y. Subtract 3, you get x plus 2 squared minus 3 equals to negative y. And finally multiply negative 1, and you get y equals to negative x plus 2 squared minus plus 3, because you multiply by negative. And that's it. That's the answer to the inverse function. So f inverse of x is negative x plus 2 squared plus 3. Now actually the easiest is the question of the domain and range of f inverse, because domain and range of f inverse is just range and domain switched. So the domain will now be the range, which is negative 2 comma infinity, and range would be the domain before, which is negative infinity up till 3. There's a simple reason for that. Domain is all the x values, whereas range is all the y values, and when you find the inverse, what do? You switch x and y, right? So you end up switching these two things, and you end up having this as your answer. Let's do something similar here. So you have f of x as a rational function. Now, if you have a rational function ax plus b over cx plus d, there are several things that you have to think about. First, you want to know the intercepts. Before I do that, let's see. We need to find the domain and range, right? Always the domain is the easier one. Domain, you just have to watch out if there's a negative inside the square root, or if you have 0 in the denominator. So if x is negative 3, this won't happen. This won't be computed. That means negative 3 cannot be an input. But anything else you can just plug in and you can calculate. So the domain, which is collection of all possible x values you're allowed to plug in, is all reals except negative 3. Now if you have a number line and you have negative 3 and you exclude this number only, then you have one interval before negative 3, another interval after negative 3. So you end up with negative infinity up till negative 3, and then another interval negative 3 up till positive infinity, and then it's a union. Okay, now that you have a union, let's see. Now you have to find the range, right? And that's when the problem starts. Unless you know the graph of this, you can't really find the range. For domain, it's easy. Just look at it. But for range, there's really not much you can do other than drawing the graph of it. So let's try to draw the graph. It's a rational function, a polynomial over a polynomial. In that case, you have a bunch of things like horizontal asymptotes, vertical asymptotes, and then the x-intercepts and y-intercepts. Okay, so first, x-intercept. Let's see, what's that? That's putting y as 0, right? So if you say 0 equals to 2x minus 5 over x plus 3, well, a fraction is 0 when the numerator is 0, so it's 2x minus 5 equals to 0, and 2x equals to 5, and divide by 2, and you get x equals to 5 over 2. For the y-intercept, you need x equal to 0, and that gives you y equals to 2 times 0 minus 5 over 2 times 0. 0 plus 3, and that's negative 5 over 3. That's your y-intercept. Then you have the vertical asymptote. Vertical asymptotes are obtained by taking this 2x, no, taking the denominator and setting it to 0. That's how you get vertical asymptotes. So denominator equal to 0, so you get x plus 3 equal to 0, so that you get x equal to negative 3. That's your vertical asymptote. And horizontal asymptote in a fraction like this, it's just simply the highest order terms. Okay, so y equals, so you just delete all these numbers, you just leave the highest order terms, and if you have this, then they cancel, you get 2, right? So horizontal asymptote is 2. And now comes the graph. What's the graph? First, horizontal asymptote is 2. And then the vertical asymptote is negative 3. And then the Y-intercept is negative 5 over 3, somewhere down here. And X-intercept is 2.5. 5 over 3 is about 2.5. So you're thinking of a graph that has these asymptotes and passes through here, so it must be this one. And the other one, you may make some more tables, plug in some values, but then you're going to see that it's this one. Now, according to this, the height of the graph can go down, down, down as much as you want, and it can go up, up, up as much as you want. But there is one place where this height does not reach, which is exactly 2, because if you have a single order polynomial, first order polynomial over first order polynomial, the graphs can never pass through the asymptotes. That's just a property if you have a linear polynomial divided by a linear polynomial. If you have like quadratic over quadratic, then you may have some portion of the graph piercing through the horizontal asymptote. Sometimes that happens, but in a first order divided by first order, that never happens. So these two curves completely miss 2. And therefore the range is from negative infinity to 2, union 2 to infinity. Now, we also have to find the inverse function. That's another challenging one. But let's just follow our steps. You replace fx by y. And then you switch x and y, meaning whenever you see y, you put x. Whenever you see x, you put y. And you want to solve for y. How do you do that? Well, you see a fraction, right? And you're trying to solve something. Fractions are evil. So what do? You multiply by that denominator, both sides, so that fractions are gone. Expand, and you get x times y plus 3x equals to 2y minus 5. Now your goal is to solve for y, and I see a y here and another y here. So you want to bring them together. In order to figure out what y is, you have to put them on the same side before you can do anything else, okay? So xy minus 2y by subtracting 2y both sides, and then also subtracting 3x both sides, you get negative 3x minus 5. And once you have brought the y's close together, what you can do is you can factor that y out, which leaves you with x minus 2 times y. And we're almost there, because in order to get rid of x minus 2, you can just divide both sides by x minus 2. And therefore, y is equal to negative 3x minus 5 over x minus 2. Okay, what else can we do? So this is your f inverse of x. Okay, so that's the answer to number 2. Number 2 is this. And in 3, the domain and range of f inverse, just as before, the domain and range of the inverse function is the original domain and range switched. So domain was this, range was this. This is going to be our domain. This will be our range, okay? So domain will be from negative infinity up to 2, and then union 2 to infinity, and range would be negative infinity up till negative 3, union negative 3 up till infinity. Okay, what is this? Well, you have to think about transformation. So first, y equals to 2 to the x. And the reason we are talking about transformations and all that is because we learned a lesson that in order to find the range, you have to draw the graph, right? So we want to start by drawing the graph. What is this graph? It's this graph. And actually, the x-axis is a horizontal asymptote. So it's a horizontal asymptote. It gets closer and closer to the x-axis. Now, if you do y equals to 2 to the x minus 5, what it does is it moves everything to the right. So it moves to the right. So what was here now is over here. And then multiplying by 3 just enlarges the stuff. Y equals to 3 times 2 to the x minus 5. It makes, stretches the y coordinate, so it's like, it's not this, but also it's more like that, okay? It still tries to get close to 0. So from this, we see that the range is all positive numbers. You can have something close to 0, it never reaches 0, so anything positive will be reached. And then it goes way up until infinity. That's your range. On the other hand, domain is all reals because there's no restriction here. You can pretty much put any number into an exponential function, 0, positive, negative, all of them are okay, so the domain will be negative infinity, positive infinity. But what's the inverse function? So let's try to find that out. First, introduce a y. Switch x and y, so you have x equals to 3 times 2 to the y minus 5. And then you're trying to isolate y, right? So you see that y, and you subtract 5, and then put that over 2, and then 3 is multiplied. So multiplication by 3 was done the last to y, right? If you look at the perspective of what operations are done to y, it's subtracting 5, raising it over 2, and then times 3. This comes last. Whatever comes last goes first. Okay, so you divide both sides by 3. Now we raised both sides by 2. How do you undo that? Well, we have a wonderful function that cancels all these exponential functions called the logs. Log with base 2 will cancel. If I apply log 2, both sides, then over here we see that log 2 and 2, they cancel. And the result is that you have y minus 5 equals to log 2x over 3. And then you add 5 both sides. And then you get y equals to log base 2 x over 3 plus 5. Okay? And then this is your inverse function. So let me just scratch this out and say this is an inverse function. And then finally in number 3, this is number 2, this is number 1. Whatever you get for the domain and range, you switch. So what was the range is now the domain. What was the domain is now your range. Next question, similar, except that what is this ln? Ln means log with base e. So if you want to draw this, well, first you have to know the graph of log. Y equals to ln of x, which is this graph. And then what is y equals to ln of 2x? Well, if you do something to, I'm supposed to do shifting first, okay? So I'm going to shift first. Before I do the 2x, I'm going to do the shifting first. So plus 7 plus 9. Well, this shifts 7 left. Okay? And then 9 goes up by 9. So what do you get? Well, before, the vertical line was the vertical asymptote of this, because you went 7 steps left. You now have a new vertical line at negative 7. And it will go like that. Plus 9 will just shift things up, so it's gonna, well, let's see, more like going up more higher because of this plus 9. Okay. All right. So that's the graph. What do we figure out by the range? The range is, well, you can go down, down, down. You can also go up, up, up. So the range is all reals. On the other hand, the domain is negative 7 is a no-no, because at negative 7 you're way down there. You're at hell. There's negative infinity down there. So this curve goes down to hell at negative 7. So it's not really there. So negative 7 is not allowed, but anything after negative 7 is allowed. You get some values there, and then up till infinity. Number 2, so this is number 1. Number 2, you have to switch x and y. First, introduce y, ln 2x plus 7 plus 9. For y, you put x. For x, you put y. And then we're going to solve for y, right? Once again, plus 9 is done the last, so that has to go first. And then you raise both over e. So these two cancel. Oh, I forgot to say, the most important rules for log is that they cancel with exponentials. If you remember the previous one, when we did this one, I took log base 2 to cancel this exponents. This property that exponential function cancels with the logs will be used a lot. So you have to see how they are done. Okay. So we have this, and then subtract 7 both sides. And then you divide by 2 both sides. So you get y as e to the x minus 9 minus 7 over 2. That is your f inverse function. Okay. Now, finally, in number 3, the domain and range of the inverse function is taking the old one, and the range now becomes the domain. The domain now becomes the range.